Now let's begin problem 2, which is about proportion. We'll see later that problem 2 has a bit of an imperfection, which is related to chapter 10 topic. I'm going to point it out a little bit later, and of course it will be perfected in chapter 10, so please forgive me at this moment. Please be patient. Alright, let's begin. The Associated Press reported that in a survey of 4,722 American youngsters aged 6 to 19, 15% were seriously overweight, meaning a body mass index of at least 30. In response to this national data, a small-scale local survey about the childhood obesity was conducted by a certain city. The city found that 24 out of 217 randomly selected local youngsters were seriously overweight. Does the city's survey suggest that its childhood obesity rate is less than the national average of 15%? Now, what is the problem? Nobody knows for sure that national average is really 15% because this too came from a survey. But for this problem, let's assume the national average is 15% because the problem says so. It says, after all, the national average of 15%. Now, how do you perfect it? That's something we're going to discuss in the next chapter, chapter 10. For now, let's assume national average is 15%, and let's move on. Okay, set up the hypotheses. 15% is the national average, so that's going to be our null value. That's clear. And what is alternative hypothesis? Less than the national average. That's a good indicator, so that we have this as an alternative hypothesis. This is another indicator too. 24 out of 217 randomly selected local youngsters. What do you get? Oh, that is 0.11, so 11% or so, according to the city's random sampling. And that's less than 15%. So that's another indicator that alternative hypothesis points toward this way, not the other way around. Anyway, here are the hypotheses, and let's test these hypotheses using the level of significance of 0.05. Okay, and I'll leave these two, hybrid and confidence interval methods, to students, and we'll talk about critical value method and probability value method. First, the critical value method goes like this. Sample statistics. Well, let's see. SE formula is P1 minus P over N, square root of all that. In this case, what is P? Well, it should come from the null hypothesis of 15%. If you calculate that, you're going to get 0.024 something. Oh, one more thing. Why is the sample size 217, not 4,722? That's because we are talking about the city's findings, so we have to use 217. Is it tricky? You bet it is. Why did I give you 4,722? Is it part of the imperfection? Partly yes, partly no. Partly yes in a sense that yes, it is imperfect. We have to use this sample size as well in order to make it really perfect. But partly no, because I want you to find out what is the right sample size in this particular case. In this case, we are doing everything about that city, and that city took 217 randomly selected local youngsters, not 4,722 nationally selected American youngsters. So we have 217 there. That's a standard error that goes to the denominator. Tricky, but here they are. Okay, now the sample statistics are done. Let's go over to the initial picture. And here we go. Outline, center, end, shade. Ending and shading, those must reflect the critical value method. Here we go. 0.15, and we want to find that critical value here. And where do we have observed proportion of 24 out of 217, about 11% or so? Does it fall into null region, blue, or alternative region, red? Close enough to null or too far away? That's going to be your decision making once you find out this critical value of x1. So let's find out. Here's the computation. End minus center over SC is your z-score. X minus 0.15 over SE we calculated earlier should be the z-score associated with 5%. Negative 1.645. It comes from the z table here. Here, z table. And look up 5% here. No, this and that. Negative 1.64, negative 1.65 is kind of pushed. So we estimate at negative 1.645, and that's how we get this value. Once you solve that equation, you get 0.11 something, really close to the observed value. But if you compare, falls kind of like this. Critical value is 0.1101 something, but observed proportion is 0.1105 something. So close, but this observed proportion falls into this null region. Therefore, null wins. Okay, I agree. This problem would have been written a little bit better if I gave you a little bit smaller alpha value, so that this critical value and this observed proportion are a little bit apart, so that the picture comes a little bit more nicely and computation is a little bit easier. But in any case, you can still do this. Alright, now that we went through the critical value approach, let's go ahead with probability value approach, and you're not gonna like it. Here we go. Probability value approach. Sample statistics are the same. We have this SE formula, P, 1 minus P over N, and square root of that. And here's the computation, 0.15, 1 minus that, over 217, square root, and then we have this as an SC, which will go to denominator. Alright, so far so good. And here's the initial picture. Outline, center, end, and shade. And end is going to come from that 24 out of 217. What do we get? Well, we get that 0.1106 approximately. It is 24 out of 217. And we want to find out this p-value. If this p-value is too big, then null wins. Too small, then alternative wins. How big is too big? How small is too small? That's the alpha value. Now, how do we find out the probability value? If I use technology, turns out 0.052 something, it's too big. So here is the conclusion, and consequently H0 wins. This is certainly greater than alpha value 0.05, which is alpha. So H0 wins. We have this conclusion. Now the purple part is highlighted in blue because it's greater than 0.05. But then again, this is when I use technology. I just use Mathematica to do the computation, which can handle t-curve and all kind of things. But if you use your t-table from our textbook in page 720, Oh, wait a minute, it's not t table, it's z table. Okay, z table is a little bit better, but still you're not gonna like it very much. Let's go to z table. And what was our z score here? Negative 1.625, so negative 1.63 is what I'll have to do. Negative 1.63, no, not this one, it's z table, it's this one. Negative 1.63, negative 1.63, 0.0516, dangerously close, but still it's a little bit bigger than 0.05, so consequently too big to disregard, so fail to reject null hypothesis, so consequently reject alternative and accept null hypothesis. We end up with same conclusion. A little bit confusing, isn't it? P is too big, P is too small. It's not as natural as critical value approach, where we have, where's the picture? Yes. This is null, so close to the null and too far from the null. Intuitively pretty clear for this conclusion, but for probability approach, the final conclusion is a little bit confusing. Do we have enough time for hybrid method? Yeah, okay, let's go with hybrid method. Sample statistics, well, the same. Initial picture, the same as critical value approach, except that we're using t measure. So this is not critical value, this is not 15% or null, but this is 0 and this is just a t-score. And as a matter of fact, excuse me, I didn't draw this picture correctly. Let me go ahead and correct this picture. Okay, I'm back and this is corrected picture, excuse me. And this mean corresponds to 15%, and this t-score of critical value corresponds to something close to 11%, so we have to have left hand side here. Sorry about the previous picture, this is the right one. And you can find out t value, and also you have to find out t bar, and we can compare. And I'm constantly using t, but it should be z. Let me correct this one as well, sorry. Okay, corrected. And the z bar, which comes from the observed mean of x bar, falls into blue region or red region. That is the key. Okay, so how do we handle that? End minus center over SE, and this end is coming from, as a matter of fact, 24 out of 217. 24 out of 217. Calculate. We have 0.110599. Yeah, that's the end. Center SC, and then we get the z-score for observed proportion. And then critical z-score is, of course, coming from the table, negative 1.645, and which is greater, z bar is greater, so z bar is actually close to 0. And consequently, what we have, H0 wins. Here is the hybrid method. As for confidence interval method, the confidence interval method does not work for proportion, so it fails. Well, we went through 4 methods, but only 2 methods are semi-important, solution 1 and 2. And personally, I would emphasize solution 1 more than solution 2, but I'm not going to prevent anybody if you use solution 2 using the p-value approach. After all, solution 2 is preferred method by our textbook. Over the years, however, I found that the students who worked out critical value method were consistently scoring higher and getting higher grades. So I would like to emphasize solution 1 a little bit more.